Stop being mean.
Stop being mean.
Okay. All right, moving on. So we have, the main thing we're going to talk about today is a central part of this chapter, which is calculating a z-score. So percentiles, we talked about being a good way to compare how you are relative to a certain set of data. And the z-score is going to help you give an even better comparison to the mean. And so the interpretation of z-score is how many standard deviations, so standard deviation would be your measure of spread, like the average distance from the mean, how many of those standard deviations you are away from the mean. So a positive z-score is going to tell you you're that far above the mean. Negative z-scores, which you can have, will tell you how far you are below the mean. So if you're below the mean, you're going to have a negative z-score. So the formula, we can write a couple different ways depending on what symbols we want to use. But it's whatever value we want, whatever value we're interested in, minus the mean over the standard deviation. So while I'm finishing this up, can you put the data, the scores, the test scores, can you put those into list 1 while I finish talking about this? So value minus mean over standard deviation. So remember we had a couple different symbols that we could use for mean and standard deviation. So value minus mean is x bar, and then we can use s sub x for standard deviation. Or we have value minus mean, so mean would be mu over standard deviation, which would be sigma.
Are we all putting these scores into list 1?
The scores, the 25 scores that we worked with yesterday. I want you to put them in list 1. Because we're about to calculate some z-scores, which means that we need mean and standard deviation for those. So that's what we're going to figure out. So I need the mean, and then I need standard deviation, which we're going to use s sub x. And I'm off to a great start today because I grabbed the marker and started writing on it the wrong way. So we're off to a great start. So we have a value in just a second. All right. X bar, this is the mean. Now I need it. 80. Exactly 80? Okay. I'm assuming the standard deviation is not exact, so give me 3 decimal places here.
6.070. I would do 6.069. Yeah, that's right.
Oh, it rounds down?
6 point. Oh, yeah.
I wanted to round it up, but then to 0.
Yeah.
Okay. All right. Value minus mean over standard deviation is the building block of the formula. So our z-score for 72, our value is 72 that we're interested in, minus our mean, which is 80, over the standard deviation, which we're going to put on the bottom, 6.0. That's not another decimal place. 6, there we go. And usually, for a reason that we'll talk about in the next section, usually your z-scores are going to go to the nearest hundredth, so 2 decimal places. we just talked about since our score is below the mean, then our z-score should come out to be negative. Negative z-scores for things that are below the mean. Should be negative 1 point something. Negative 1 point what? 3.2. So negative 1.32. In other words, we're about 1.32 standard deviations below the mean. Well, one standard deviation would be 6.069, so about 6. So about 6 would be one standard deviation away. 72 is 8 below the mean, so a little bit more than that. So that's how we get the z-score being about negative 1.32. So you can start to kind of build that estimate for what your z-score, about what your z-score is going to end up being. So go ahead and calculate these other z-scores.
Can you have a z-score that equals the mean?
You can have a score that equals the mean.
Or no, I meant.
So make a prediction as to what the z-score is going to be if the value that we're looking at is the mean. Because remember, we're measuring how far away we are from the mean. So you should be able to make a guess as to what the z-score is going to come out to be.
Sometimes I think Oregon will have an mean the same stuff as
One more time. I tried to be fancy, and I should have just written it. It would have been faster.
No, I applaud the fancy.
There we go. We did it. Here's 93. Here's 80. So that's whatever value we're looking at goes there. Sometimes it goes the other way, which we'll look at next section. Sometimes we'll have the z-score or the percentile, and we'll work backwards to get what value is in the 90th percentile, or what value has a z-score of 2. Two decimal places. What did this come out to be? 2.14. Asked to make a prediction. Hopefully our prediction was right. What is it? 0. Because remember, we're measuring how far above or below the mean we are. So if we're exactly at the mean, then our z-score is going to be 0. So this allows us to make comparisons with how far away we are from the mean, how far above or below the mean we are. So let's talk about another way that we can use z-scores. Another way that we can use z-scores is to have a comparison between different sets of data. So we have this statistics test. Remember, for the stats, the mean was 80, and a standard deviation was this. Then there was a chemistry test. Completely different set of data, which had a mean of 76 and a standard deviation of 4. And so what we're going to do is we're going to use z-scores to make a comparison to say how good is the 86 on the statistics test versus the 82 on the chemistry test. How good are those in comparison to each other? So we'll start with stats because it's better. And so we have our value 86. Our value is 86 minus the mean, which is 80, over the standard deviation. This should be pretty, since standard deviation is 6 and we're looking at 6 above, this should be pretty close to 1, but not quite. What do we got? Again, very close to 1, but not quite. All right. Chemistry. Z-score for chemistry is going to be you need to find in the problem the building blocks of the formula. Value 82. 82 is the score. Minus the mean, which is 76. 76. Over the standard deviation, 4. 1.5. Standard deviation was 4. It was 6 above the mean. So that means for standard on a scale of 4s, we're 1.5 standard deviations above the mean. That's what the z-score tells us. So if we wanted to write a sentence to talk about this, we could say, although Jenny got a better score on the stats test, her chemistry score, let's capitalize chemistry score was higher relative to the rest of the class. So it helps us say, well, it depends on whether we're talking what we mean by, which one did she do better on? Which one did she get the higher score or the higher grade on? Well, it was stats. But which one did she score better on in comparison to the rest of the class and in comparison to how difficult the tests seem to be? Then it would be chemistry. So the z-score helps us, it's also called a standardizing score because it helps us have a basis, a consistent standard for how we can compare different groups of data that have different means and different standard deviations. It can help us make those more direct comparisons. Questions on that? Okay, one more thought for you. Oh, homework. Actually, I'll do that. Yeah, let's just leave it there. I'll do that on Monday and Tuesday. This homework assignment, if you watched yesterday, then you should have it already. This is not a new homework assignment. Don't forget, all the homework is due on the chapter test. Oh, speaking of chapter test, get in there.
Okay, sorry.
I was about to say it, and then,
Sure, finish
okay.
going.
I am looking right now at doing a week from Wednesday for our next test. This is only 2 sections, so we'll practice some more on Monday and Tuesday. We'll do the section 2 notes on Wednesday and Thursday, and maybe finish them up on Friday at our 10:30 time. And then I'll be available on Monday for. On Monday we might meet or do some practice questions or take some questions or something. Tuesday and Wednesday, you'll get a chance to review and ask questions, and then on Wednesday I'll open up the test and you'll take it. That's what I'm planning to do. Is that good with everybody? All right.
Sorry, I put you on there.
It's okay. All right, so a week from Wednesday. I'm going to mark that in the calendar.